Accelerated learning binaural beats. Listen to these California Green Building Standards Code guidelines to review for the California Supplemental exam. Ensure you consult the most up-to-date version of the California Building Standards Code, Title 24, Part 11, CalGreen, Chapter 5, Non-Residential Mandatory Measures. Play the audio before you sleep or when you wake up in a relaxed state. Repeat the code guideline and use your imagination to apply it to what you already know. Let this learning tool guide you, knowing you will succeed. Let's begin. Title 24, Part 11 is known as the California Green Building Standards Code, or CalGreen Code, or CalGreen. It is Part 11 of the 13 parts of the California Code of Regulations, which is known as the Title 24, also referred to as the California Building Standards Code. What is the purpose of CalGreen? The purpose of CalGreen is to improve the health and safety and general welfare through guidelines that reduce the negative impact or produce a positive impact and encourage sustainable construction practices in the following categories: planning and design, energy efficiency, water efficiency and conservation, material conservation and resource efficiency, environmental quality. Agencies with authority over CalGreen. These include the Building Standards Commission, the Division of the State Architect, the Department of Housing and Community Development, and OSHPD. The California Energy Commission also provides energy regulations. The Building Standards Commission proposes regulations for both state-owned building and non-state-owned buildings. How to use the CalGreen Code. To use the CalGreen Code, first establish the type of occupancy for your building. Next, verify which state agency has authority for that occupancy from Section 103 to 106 in Chapter 1 of CalGreen. Whether it's the Building Standard Commission, the Department of Housing and Community Development, or the Division of the State Architect, and the Office of Statewide Health and Planning Development, verify which state agency has authority over your occupancy. For state-regulated buildings and structures, CalGreen applies to state-owned buildings, both Cal States and universities in California. The energy efficiency standards regulated by the California Energy Commission must be consulted when necessary. Residential buildings are also regulated by the Department of Housing and Community Development. Public elementary, secondary schools, and community colleges are regulated by the Division of the State Architect. Historical buildings are also regulated by the State Historical Building and Safety Board. Acute care hospitals are regulated by the Office of Statewide Health Planning and Development, or OSHPD. Gray water systems are regulated by the Department of Housing and Community Development. And for occupancies where no particular agency is responsible, the Building Standards Commission is in charge. Chapter 5, Non-Residential Measure Provisions that apply to individual sections. Chapter 5, Non-Residential Mandatory Measures that apply to individual sections include newly constructed buildings, building additions of 1,000 square feet or greater, or building alterations with a permit valued at over $200,000. This can be found from CalGreen Chapter 3. Again, to review, Chapter 5 non-residential measure provisions are triggered for newly constructed buildings, for building additions of 1,000 square feet or greater, or building alterations with a permit. As of July 2024 version updated CalGreen Code, Chapter 5 non-residential mandatory measures will be reviewed in this recording. This recording will cover Chapter 5, Non-Residential Mandatory Measures. Non-residential occupancies include Groups A, B, I, L, and M occupancies. Chapter 5 starts with Section 5.1, which starts with applicable guidelines for alterations to existing buildings. There are specific sections that this guideline in this chapter will apply to. The Building Standards Commission regulates buildings for those alterations to existing buildings where the combined altered floor area is 100,000 square feet or greater. It's the same for additions to existing buildings. Those alterations to existing buildings where the combined altered floor area is 100,000 square feet or greater, or the same for additions to existing buildings that are 100,000 square feet or greater, those are regulated by the Building Standards Commission. However, the Division of the State Architect regulates buildings that apply to alterations to existing buildings where the combined altered floor area is 50,000 square feet or greater. For Division of the State Architect buildings, for 50,000 square feet or greater, the Division of the State Architect is in charge for their buildings, such as schools and community colleges. What percent of an alteration or addition to an existing building's primary structural elements and existing building enclosures must be maintained? According to CalGreen, 45% minimum combined must be maintained. That is, 45% of an existing building's primary structural element and existing building enclosure must be maintained. Window assemblies, insulation, and portions of buildings that are structurally unsound or contain hazardous materials remediated should not be included in the 45%. What is the intent of SWIP, or the Stormwater Pollution Prevention Plan? The intent of SWIP is to prevent loss of soil through wind or water erosion and stormwater management. New construction and additions, stormwater pollution prevention for projects that disturb less than 1 acre and are not part of a larger plan of development. What are the requirements? The requirements for new constructions and additions in terms of SWIP for projects that disturb less than 1 acre and are not part of a larger plan of development must comply with local ordinances for stormwater management and erosion control, and must comply with best management practices found in CalGreen, or BMPs. There are generally 2 types of best management practices, or BMP, lists in the CalGreen 5.1 section. There's a list for sediment and erosion control best management practices and a list for good housekeeping best management practices. Part of the sediment and erosion control best management practices, the following means of compliance are included: schedule construction during dry weather, preserve natural features, provide drainage swales, provide hydroseeding and mulching, protect slopes, protect storm drain inlets, provide perimeter sediment control, provide sediment traps, stabilize construction exits, and provide for wind erosion control. In terms of good housekeeping BMPs, the list is as follows. First, provide dewatering activities. Provide for material handling and waste management. Provide for building material stockpile management. Provide washout area management. Provide equipment and vehicle fueling. Provide vehicle and equipment cleaning off-site. And finally, provide for spill prevention and control. SWIP compliance and enforcement. What are some of the guidelines? To comply with SWIP, or stormwater pollution prevention, and enforcement, you must indicate one of the requirements implemented from the best management practices on your construction documents. The contractor submits and receives approval of the Stormwater Pollution Prevention Plan best management practice that will be utilized by the authority having jurisdiction. Inspection is then carried out on site by the separate enforcing agency. Let's discuss stormwater pollution prevention, or SWIP, for projects that disturb greater than 1 acre of land or disturb less than an acre of land but is part of a larger common plan of development. First, per the National Pollution Discharge Elimination Permit, we must provide for post-construction runoff to match pre-construction runoff. Again, per the National Pollution Discharge Elimination System Permit, post-construction runoff must match pre-construction runoff. Stormwater runoff reduction can be provided through on-site stormwater use, interception, evapotranspiration, infiltration through non-structural controls such as lid or low-impact development, or if stormwater can't be captured non-structurally, then we can implement approved structural controls. Remember, these measures should be considered during the initial design process for approved integration into site development. All of this is for stormwater discharge associated with construction and land disturbance activities that are issued by the State Water Resources Control Board. Again, for stormwater pollution prevention for projects greater than an acre of land or less than an acre of land but part of a larger common plan of development, make sure you comply with the NPDES permit, which provides that post-construction runoff must match pre-construction runoff, and stormwater runoff reduction can be achieved through one of the means provided, such as stormwater use, interception, evapotranspiration, infiltration, or non-structural controls such as lid, low-impact development. And if stormwater runoff can't be captured non-structurally, then you can implement an approved structural control. The next section of Chapter 5, Non-Residential Mandatory Measures, still part of 5.1, describes bicycle parking guidelines under the authority of either the California Building Standards Commission, BSC, or under the Division of the State Architect, DSA. The intent is to promote use of bicycles as an alternative means of transportation by ensuring new construction projects or alterations and additions provide for both short-term and long-term bicycle parking accommodations. The goal is to promote the state's air quality and promote bikes as an alternative means of transportation to improve air quality across the state. Let's review short-term bicycle parking for new buildings, alterations, and additions. If the project plans to generate visitor traffic, then you must provide permanently anchored bicycle racks 200 feet of the visitor's entrance. It must be visible to visitors. You must also provide bike racks for 5% of new visitor motorized vehicle parking spaces added, with a minimum of 1 2-bike capacity rack. Let's consider an example. But before we consider an example, do remember there is an exception to this short-term bike parking. The exception is for an addition and alteration. If less than 9 visitor vehicle parking spaces are being added, then bike racks are not required. Let's consider the example. If we are providing 42 new visitor motorized vehicle parking spaces, then 5% of that is 42 times 0.05, which equals 2.1. We always round up, so we round up to 3, which means we must provide racks to accommodate 3 bicycles for short-term parking requirements. Next, let's discuss long-term bicycle parking for new buildings. If 10 or more tenant-occupant spaces are being added, then we must provide secure bicycle parking for 5% of the tenant-occupant vehicular parking spaces. That means a minimum of 1 bicycle parking facility, regardless. or 5% of the tenant-occupant vehicular parking. The same requirement for new buildings also applies for an addition or alteration or a new shell building in a phased project. So just remember that new buildings are the same requirement for addition, alterations, and new shell buildings, which means for 10 or more tenant-occupant spaces, you must provide secure bicycle parking for 5% of tenant-occupant vehicular parking spaces with a minimum of 1 bicycle parking facility. And for long-term bicycle parking, this applies for Building Standards Commission regulated projects. We'll discuss DSA regulated bicycle parking in just a bit. But to first discuss an example for long-term bicycle parking requirements, if we have 216 new tenant-occupant spaces that are being provided on a new building project, then 5% of that requires 10.8 bicycle parking facilities. We must round up, which means we must provide 11 secure bicycle parking facilities. Remember, it's 5% for short-term and long-term, so that's easy to remember. Next, let's discuss long-term bicycle parking under the Division of the State Architect Regulated Schools and Community Colleges parking requirements. And this is divided into 2 sections, one for students and one for staff, so the requirements are different. First, let's discuss student requirements. For DSA regulated schools for students, we must provide permanent anchored bicycle racks that are conveniently accessed, and we must provide a minimum of 4 2-bike capacity racks per new building. For students, permanent anchored bicycle racks, conveniently accessed, with a minimum of 4 2-bike capacity racks for new buildings. Next, let's discuss DSA regulated buildings for community colleges and schools for staff bike parking requirements. For staff bike parking requirements under DSA regulated buildings, we must provide secure bicycle parking, a minimum of 2 staff bicycle parking spaces per new building. These bicycle parking spaces must be convenient from the street or staff parking. And an acceptable bike parking facility should meet one of the following requirements. It must be either covered and lockable as an enclosure with anchored racks, or lockable bike rooms with anchored racks, or lockable lockers with anchored racks. Those are the 3 distinctions or requirements for a bicycle parking facility, which is different than a bicycle rack under the student bicycle parking requirements. The next set of requirements in 5.1 facilitate electric vehicle charging capability by installing raceways for future electric vehicle supply equipment at the time of new building construction. Having infrastructure pre-installed allows EV charging stations to be applied easily at a future date. First, let's discuss what building types are electric vehicle requirements for. Electric vehicle requirements are generally for new construction, new buildings on new or existing sites with new or pre-existing parking stalls. We'll discuss some updates to existing projects with additions and alterations in a few minutes, which have new requirements as of July 2024. For this section, let's focus on new construction and new buildings. EV charging must comply with CalGreen and provided in accordance with regulations in the California Building Code and the California Electric Code. Electric vehicle capable space. Let's define what that means per CalGreen standards. An electric vehicle capable space is a vehicle space with an electric panel space and a load capacity to support a branch circuit and necessary raceways, both underground and or surface mounted, to support EV charging at some future date. Also remember too that accessibility is not required for EV capable spaces because the charging service is not yet provided. Let's define an electric vehicle supply equipment, or EVSE. An electric vehicle supply equipment, or EVSE, is the conductors, including undergrounded, grounded, and equipment grounding conductors, and the electric vehicle connectors, attachment plugs, personnel protection system, and all other fittings, devices, power outlets, or apparatus installed for the purposes of transferring energy between the premises wiring and the electric vehicle. Let's define an electric vehicle charging station, or EVCS. An electric vehicle charging station is one or more electric vehicle charging spaces that are served by an EVSE or receptacle. This must provide accessibility to an electric vehicle charging station, which again is an EV-capable space with an EVSE or EV supply equipment. Why do we need accessibility for an EV charging station? Because the charging service is provided. To review, unlike an electric vehicle capable space that has charging service that's not provided yet, an electric vehicle charging station has charging service provided. You can actually drive up and charge your vehicle. That's the way to remember it. Therefore, an EVCS must abide by accessibility guidelines per Chapter 11B. Electric vehicle capable space requirements. Electric vehicle capable space must provide the following: a raceway with 1-inch diameter or greater that terminates close proximity to the space, a service panel space that's dedicated 208 240 volt 40 amp minimum branch circuit for each EV capable space, with delivery of 30 amp minimum to an installed EVSE at each EVCS. Electrical system and transformers must also have capacity to supply full rated amperage at each EV capable space. And finally, sub-panel circuitry label must show EV capable. To review, the electric vehicle capable space requirements again must have the following: a raceway of 1-inch diameter or greater that terminates in close proximity to the future EV space. The service panel must have a space that's dedicated at 208 240 volt 40 amp minimum branch circuit for each EV capable space, with delivery of 30 amp minimum to an installed EVSE at each EVCS. And electrical system and transformers must have capacity to supply full rated amperage at each EV capable space. And finally, the sub-panel circuitry must have a label showing EV capable for EV capable spaces. Parking spaces designed as future electric vehicle charging spaces, such as EV capable spaces, count as one standard automobile parking to comply with any applicable minimum parking space requirements by the AHJ. All of that is to say that per the AHJ minimum standard parking requirements, you can use your EV capable spaces to count towards standard automobile parking. In CalGreen 5.1, Table 5.1.6.5.3.1, it provides a table for figuring out, according to the total number of actual parking spaces provided in a new building, how many are you going to need for electric vehicle capable spaces and how many are you going to need for electric vehicle charging stations. If the total number of actual parking spaces for a new building is between 0 to 9, then 0 EV capable spaces are required and 0 electric vehicle charging spaces are required. If the total number of actual parking spaces for a new building is between 10 to 25, then 4 EV-capable spaces are required, and 0 of those need to be electric vehicle charging stations. If you're providing 26 to 50 actual parking spaces, then 8 EV-capable spaces are required. Of those 8, 2 must be electric vehicle charging stations. If you're providing 51 to 75 total actual parking spaces on a new project, then 13 are required to be EV-capable, and of those 13, 3 are required to be electric vehicle charging stations. If 76 to 100 total actual parking spaces are provided on a new project, then 17 must be EV-capable spaces and 4 EV charging stations of those 17. If 101 to 150 actual parking spaces on a new project, then 25 are required to be EV-capable, and of those, 6 must be EV charging stations. If 151 to 200 total actual parking spaces, then 35 are required to be EV-capable and 9 EV charging stations. And finally, if 201 and over total actual parking spaces on a new building project, then the number of required EV-capable spaces is 20% of the total number of actual parking spaces, and the number of EVCS is 25% of that total. Three important notes underneath this table that provides for the number of EV-capable spaces and EV charging stations. The first note is the calculation of spaces must round up to the nearest whole number. The second is that the number of required electric vehicle charging stations or electric vehicle capable spaces with EVSE from column 3 count toward the total number of required EV capable spaces shown in column 2. And the third note is at least one level 2 EVSE shall be provided. Let's discuss the regulations that refer to levels of standards for chargers. Let's understand the difference in each level and the terminology. In CalGreen, you'll see the terminology of level 1 EV charging receptacle. A level 1 EV charging receptacle refers to an electric vehicle charging station that has an electric vehicle supply equipment that's rated at 120 volts, 20 amp minimum branch circuit and receptacle. Next, we have a low power level 2 EV charging receptacle. That refers to a 208 240 volt, 20 amp minimum branch circuit and receptacle. Next, we have a high power level 2 EV charger. This refers to a 208 volt, 240 volt, 30 amp minimum EV charger that's connected to the premises electrical system and is capable of charging electric vehicles. And level 2 EVSE. A level 2 EVSE is a 208 240 volt, 40 amp branch circuit, and electric vehicle charging connectors, attachment plugs, and all other fittings and devices, power outlets for the purpose of transferring energy between the premises wiring and the electric vehicle. So understand the differences again between level 1 EV charging receptacle, low power level 2 EV charging receptacle, and the way to remember those two is a level 1 is at 120 volts, low power level 2 is at a 208 240 volt, but both provide 20 amps minimum. Then we have a high power level 2 EV charger, which is at a 208 240, just like the low power level 2, but instead of a 20 amp minimum, high power level 2 says you must provide a 30 amp minimum EV charger connected to the premises electrical system, capable of charging the electric vehicles. And finally, a level 2 EVSE, in that it provides 208 240 volts, just like a high power level 2 EV charger, except this level 2 EVSE increases the amperage to 40 amp branch circuit and EV charging connectors, attachment plugs, and all other fittings and devices and power outlets for the purposes of transferring energy between the premises wiring and electric vehicle. Level 1 chargers, it's common to get around 4 miles of range per hour of charging. With level 2, it's common to get around 20 to 30 miles of range per hour of charging. So a level 2 is a higher power, which means faster charging, but it's also more expensive as a system. Remember that level 2 charging stations use AC, or alternating current. Electric vehicles have chargers built inside the vehicle to convert AC power to direct current DC power for the battery. Another category of chargers mentioned in CalGreen are called DCFC, or direct current fast chargers. These convert AC power to DC within the EV charging station and deliver the DC power directly to the battery, which is why they charge much faster than a level 1 and level 2 charger. Let's discuss requirements for electric vehicle charging stations, or EVCS. These are new updates as of July 2024. Based on the number of electric vehicle charging stations required, which means an EVCS is an EV-capable space with an EV supply equipment, or EVSE. That electrical vehicle charging station can be a level 2 or a DCFC. However, at least one level 2 EVSE shall be provided. The second new update is that if we decide to install a direct current fast charging EVSE, or let's say that another way, if we decide to install a DCFC EVSE, each DCFC EVSE is permitted to reduce the minimum number of required EV-capable spaces without EVSE or EVCS with level 2 EVSE by 5, and reduce proportionally the required electrical load capacity to the service panel or subpanel. These are supplements to the code, which go into effect as of July 2024. Reminder to always check the latest version of CalGreen code. There's one more electric vehicle charging station update. If you decide to install 2 low-power level 2 EV charging receptacles, then you can reduce the minimum of required EV-capable spaces by 1. Let's review this flashcard again. The requirements for electric vehicle charging stations is based on the number of electric vehicle charging stations required. The EVCS provided can be a level 2 or a DCFC. But remember, at least one level 2 shall be provided. Now, if we decide to install a DCFC, then for every DCFC, we are permitted to reduce the minimum number of required EV-capable spaces without an EVSE or an EV charging station with a level 2 EVSE by 5, and reduce proportionally the required electrical load capacity to the service panel or subpanel. And if you decide to install 2 low-power level 2 EV charging receptacles, then you can reduce the minimum required number of EV-capable spaces by 1. There are many combinations for compliance, whatever the example, but let's practice a simple one together. If 55 total actual parking spaces are provided in a new building project, CalGreen table says you need 13 EV-capable spaces, with 3 of those as electric vehicle charging stations, which means equipped with EVSE and ready to charge. If I decide to install 2 DCFC EVSEs using the allowed 5 EV-capable spaces to 1 DCFC ratio, then 2 DCFCs count towards 10 EV-capable spaces. The third EVSE will be a level 2 EVSE. Remember to satisfy the requirement of providing at least one level 2. So the final count of 55 total actual parking spaces means we need to provide 3 electric vehicle charging stations, 2 DCFC EVSEs, and 1 level 2 EVSE. Again, there are many ways to solve this problem. This is just one way to solve this problem. Automatic Load Management System, or ALMS, ALMS, is permitted for electric vehicle charging stations. ALMS may reduce the load capacity to an electric vehicle supply equipment with a minimum of 30 amps when charging one vehicle, or 3.3 kilowatts for multiple electric vehicles. So this is a system that allows you to reduce the load capacity to an EVSE. Next, let's discuss the accessible EV charging stations. As we said before, an EV-capable space does not need to be accessible per Chapter 11B guidelines because it does not provide a charger yet. However, an EV charging station must provide for accessible spaces because you can charge. A table is provided in CBC Chapter 11B 228.3 with the following columns. The first column provides for the total number of EVCS facilities. So first you would figure out the number of electric vehicle charging stations from CalGreen code, then come to this table in Chapter 11B. And if you have 1 to 4 electric vehicle charging facilities, then you read across the row and it says you need to provide 1 van accessible. So one of those EVCSs must be van accessible. However, 0 of those need to be standard accessible and 0 need to be ambulatory accessible. Next, you go down the line in the rows. If you're providing 5 to 25 electric vehicle charging stations, then 1 needs to be van accessible, 1 needs to be standard accessible, and 0 ambulatory accessible. If you're providing 26 to 50 EVCSs, 1 needs to be van accessible, 1 standard accessible, and 1 ambulatory. If 51 to 75 total number of electric vehicle charging stations, then 1 van accessible, 1 standard accessible, and 2 ambulatory. If 76 to 100 total number of electric vehicle charging stations, then 1 must be van accessible, 3 standard accessible, and 3 ambulatory. And finally, if you're providing 101 and over total number of EVCS, then 1 plus 1 for each 300 must be van accessible. For standard accessible, 3 plus 1 for each 60. And for ambulatory, 3 plus 1 for each 50. Make sure that you install EV-capable spaces per Chapter 11B near a building's entrance for future compliance with accessible guidelines. To review, power in watts equals I times V, I amps times V volts. 1,000 watts equals 1 kilovolt amps. Kilovolt amps, which you'll often see in the electric vehicle power requirement guidelines section, is used to rate generators and transformers. Updated as of July 2024 code, it provides a table for electric vehicle charging station power allocation to determine the total power in kilovolt amps required based on the total number of actual parking spaces. The first requirement is use any kilovolt amp combo of EV-capable spaces, low power level 2, or DCFC EVSEs, and at least 1 level 2 EVSE shall be provided. Let's review an example. You have 55 actual parking spaces. We know from the previous calculation that we needed 3 electric vehicle supply equipment spaces, or 3 electric vehicle charging stations that have that capacity of an EVSE. In the power allocation table, separate than the previous table, which we used to determine the number of electric vehicle spaces and electric vehicle charging stations, this table, you must find the row where you have your total number of actual parking provided, in our example 55, and read across that row. It shows that you will need 85.8 total kilovolt amps in any combination of low power level 2, DCFC, or EV capable spaces. So that's how much kilovolt amps you need to provide or have a capacity to provide for whatever combination you provide per the previous table. As of July 2024, new updates for electric vehicle requirements for additions or alterations to existing buildings or parking facilities are as follows if it meets the following any one of these three. First, if construction work includes an increase in the power supply to an electric service panel as part of the parking facility addition or alteration. Or if a new photovoltaic system is installed covering existing parking structures. And finally, if an addition or alteration and the scope of work requires an increase in the power supply to electric service panels. For any addition or alteration to an existing building or parking facility, if the construction work includes an increase in the power supply, or if a new photovoltaic system is being installed, or if there is an increase in the power supply to a service panel, then the next updates will apply. If any of the three mentioned criteria is met, as we just said, then for existing buildings and parking areas without previously installed EV-capable infrastructure, the project must comply with all the tables we mentioned previously in 5.1 of CalGreen for EV charging according to actual parking spaces that are being added or altered. Let's say that again. If any of the three mentioned criteria is met, then for the existing buildings and parking areas without previously installed EV-capable infrastructure, the project must comply with all the tables in EV for CalGreen according to the total number of actual parking spaces that are being added or altered. That's the key. Total number that's being added or altered to the existing building. However, if an EV-capable infrastructure is already available at an existing parking facility, then the building that is undergoing an alteration, it must comply with all the EV charging requirements for total actual parking spaces being added or altered. The next section of 5.1 was updated for EV infrastructure guidelines for medium to heavy duty charging at warehouses, retail, and grocery stores. CARB, or California Air Resources Board, and the Building Standards Commission worked together to create the guidelines in this section. The goal was to provide 180,000 medium to heavy duty zero emission vehicles by 2030. Electric vehicle charging readiness requirements for warehouse, grocery stores, retail stores, offices, manufacturing facilities with planned off-street loading spaces. Let's discuss what the EV charging requirements are. They must provide transformer and panels to meet minimum power requirements. Construction documents must indicate off-street loading for medium and heavy-duty charging cabinets. Raceways at the main panel serving the area of future medium and heavy-duty EVSEs. And raceways must be sufficiently sized to carry the additional load to future locations. Let's discuss power requirements for medium and heavy-duty EVSEs. Power requirements for medium and heavy-duty EVSEs. We follow the table provided in 5.1, which starts by selecting the facility type, then moving across the row and selecting the building's size in square footage, which then provides the requirement of the number of off-street loading spaces. And finally, the last column shows the additional capacity required for raceway and busway and transformer and panels. These are either in 200 or 400 kilovolt amp. Updated as of July 2024, A new section is added for EV charging at public schools and community colleges under the jurisdiction of the Division of the State Architect. For the most part, it is written exactly the same per the requirements previously mentioned in 5.1 for new construction projects, including similar tables and requirements. The next section, 5.1, discusses guidelines for reduction of light pollution, which is disruptive to the environment, wildlife, and humans. The goal of this section is to maintain dark skies and ensure that new projects reduce backlight, uplight, and glare, or bug, from exterior light sources. Light pollution reduction that meets the requirements of the California Energy Code and reduces light and glare from interior and exterior light sources leaving the building site. We can check lighting zones 0 through 4 in the California Energy Code and follow which lighting zone our building pertains to. The next section of 5.1 discusses grading and paving requirements to ensure that newly constructed project sites, additions, and alterations that redefine drainage paths are designed to keep surface water from entering the building. Construction documents must show site drainage and how it is prevented from entering buildings, and we can manage surface water through the following means. We can provide swales, water collection and disposal, French drains, water retention gardens, the top of the foundation elevation above the elevation of a street gutter must be not less than 12 inches, and other ways to keep surface water away from buildings and aid in groundwater recharge. The exception, this guideline does not apply to any addition or alteration that is not changing the drainage paths on the site. The intent here again is to keep water and moisture from entering buildings. The final section of 5.1 is about shaded trees for surface parking areas, landscape areas, and hardscape areas. This is for projects under the Division of the State Architect. The requirements are for surface parking, you must use a number 10 size tree that's installed to provide 50% shade of the parking area within 15 years. Then, for landscape and hardscape, you must use a number 10 size tree to be installed to provide at least 20% shade of landscape or hardscape areas within 15 years.